So let's have a look at why radioactive elements or radioactive nuclides will start to fall apart. Why do they spontaneously radioactively decay? Let's have a look. First thing we know is that it mostly depends upon either their mass. If it's too heavy, they'll start to decay, or the proton to neutron ratio. They like it to be roughly 1-to-1 for a little while at least, and if we get too many protons, it'll fall apart. Too many neutrons, it'll fall apart. Now this black line along the center, so that's the 1-to-1 line. Okay, you can see for the first 20-ish, it kind of follows it, but then it starts to go up a little bit. That's fine. So what we have here, these black ones, these guys are the stable nuclides. Okay, and what you might notice a pattern is that if it gets too high on the neutron numbers, this is the neutron axis, this is the proton axis. If it gets too high on the neutron axis, it'll go through beta negative decay. All right. Now, the thing about beta negative decay is that it actually makes an extra proton plus an electron. Whereas if it gets too low on the proton axis, so if it gets too high on the proton axis, it'll go through beta positive, which makes an extra neutron plus a positron. And up here is where alpha division starts to be really big. And what you'll see is that beyond this point here, 82, it just starts to get heavy. It gets too heavy and it falls apart. And that's why it's going through alpha. Because when you go through alpha decay, you can shed large amounts of mass. So let's have a quick look at these conditions in a bit more detail. The neutron to proton ratio is too high, so too many neutrons. Basically, when there's too many neutrons, it decays to form a proton and a beta particle. This is beta negative decay, and it looks like this. So this is the atomic number, that's the mass, and we see iodine here decays into xenon, and you'll see that the mass stays the same, but you get a beta negative particle. That's pretty rad. If the neutron to proton ratio is too low, so you've got too many protons, basically you will go through beta positive decay to where a proton goes to a neutron. And you see here the atomic number goes up, proton goes to a neutron, and then you'll release a positron at the same time. So here's a sodium which does not have enough neutrons, so it's like, I do not know how to react. So what it will do is it will release a positron, which is that boy just here, and this number, the atomic number, will go down, but the mass stays the same. Then, if we just have too many nucleons, if the thing is too heavy, and this is everything from uranium up, they're called the transuranic elements. Basically, if you're a transuranic element, you have too many nucleons, and it doesn't like it. So what it's going to do, so Z above 83, remember uranium is 82, that should be an 8. And so you lose a helium nucleus, which is 2 protons, 2 neutrons. So here we have thorium, the most metal of all elements. Not technically, not in the chemical sense, just that, they've got the Thor, so super metal. And then it loses a helium atom, or helium nuclide, or nucleus. There's no protons, there's no electrons in this. And you go down to radium, still radioactive, at 88, and your mass is 226. And that's where we're at. Those are the reasons that it will fall apart. Alright, see you later. Any questions? Put them in the comments below.